A million miles from Earth, a golden eye is staring into the abyss. It's silent, it's cold, and it is patiently gathering the ghost light from the very beginning of time. We're talking about the genuine possibility of imaging new alien worlds, sniffing their air for signs of life, and capturing the light of the very first stars to ever ignite in the cosmic dawn. The next year won't just be about discovery. It has the potential to be a revolution. These are the discoveries the James Webb Telescope is poised to make, and it's all happening starting now. In the next 12 months, the James Webb Space Telescope won't just show us new pictures of the cosmos. It's poised to shatter our understanding of reality. The discoveries on its immediate horizon are so profound, they promise to unravel the very fabric of astrophysics, forcing us to ask questions we once thought were reserved for science fiction. We are on the verge of discoveries that will not only rewrite our science textbooks, but will compel us to reevaluate everything. We thought we knew about our place in the universe.
The hunt for Earth 2.0 for centuries, the idea of other worlds was pure speculation. Then, we began finding them, thousands of them, but they were mostly just shadows, tiny dips in a star's light telling us something was there. We could guess their size, their orbit, but we couldn't truly see them. That era is officially over. The James Webb Space Telescope is now a planet hunter of unprecedented power, and its next targets are the most tantalizing in the galaxy. Its secret weapon is a technology called a... Imagine trying to spot a firefly next to a brilliant The searchlight is the star, and the firefly is the planet. Webb's coronagraph is an exquisitely precise mask that blocks the blinding glare of the star, allowing the faint, reflected light of the planet to emerge from the darkness. This gas giant, about 6 to 12 times the mass of Jupiter, was a transformative moment for astronomy. It proved that technology works, and works beautifully. If Webb can do this, what else can it find? Located just 40 light-years away, this system is a cosmic marvel, home to 7 Earth-sized rocky planets, with at least 3 orbiting in the habitable zone. For years, it has been the poster child for the search for another Earth, but Webb's initial observations have revealed it's far more complex and mysterious than we ever imagined. The innermost planet, TRAPPIST-1b, was at first thought to be a bare, airless rock, but startling new data suggests it might be hiding a secret ether, an atmosphere thick with carbon dioxide, veiled by a strange haze, or it could be a world convulsing with intense volcanic activity. The fact that we can even debate the geology of a planet 40 light-years away is a monumental leap. Over the next year, Webb will continue to stare at the TRAPPIST-1 worlds, moving from one to the next, hoping to unravel this mystery and determine if any of them are truly habitable. This isn't just theory. It's already working miracles. They are absolutely everywhere, and we know they are teeming with planets. We are mapping their orbits, we are seeing them as individuals, and we are choosing the most promising candidates for an even deeper look. The next year of Webb observations promises to deliver a gallery of new worlds, moving us closer than ever to finding a planet that looks, and maybe even feels, like home. Because M-dwarfs are so dim, their habitable zone, the orbital region where liquid water could exist on a planet's surface, is much closer to the star. This makes them perfect targets for Webb. A dedicated program will leverage hundreds of hours of observation time to scrutinize planets orbiting these stars, aiming to answer the ultimate question: could they host life? A huge portion of Webb's time over the next year is dedicated to a single, profound goal: finding and characterizing rocky worlds around other stars. Specifically, Webb is turning its golden eye towards M-dwarf stars. In 2022, Webb flexed its planet-hunting muscles and captured its first-ever direct image of an exoplanet, a world named HIP 65426b. The answer lies in its upcoming mission list, a catalog of cosmic treasures selected from thousands of competitive proposals from astronomers around the world. These are the most common stars in our Milky Way, smaller, cooler, and dimmer than our Sun. One of the most famous M-dwarf systems, TRAPPIST-1, remains a top priority. This is the new frontier of exploration. We are no longer just counting planets, we are beginning to know them. The secrets in starlight. Finding a rocky planet in the habitable zone is only the first step. A world can be the right size and the right temperature, but without an atmosphere, it's just a sterile rock in space. To truly find a world with a potential for life, we have to be able to taste its air. Different gases in that atmosphere: oxygen, methane, carbon dioxide, absorb specific colors or wavelengths of light. By capturing the starlight that has passed through this atmospheric veil, Webb can see which colors are missing. Those missing pieces create a barcode, a chemical fingerprint that tells us exactly what that alien air is made of. And that is Webb's second, and perhaps most profound, superpower. It is a cosmic chemist, capable of sniffing the atmospheres of worlds light years away. Webb has already successfully analyzed the atmosphere of giant exoplanets, proving that the building blocks of complex chemistry are present. But the ultimate goal, the discovery that would change human history, is to find a biosignature, combination of gases that is so chemically unbalanced that it could only be produced by life, and interpreting the results is fraught with peril. The ongoing study of the TRAPPIST-1 system shows that what might look like an airless rock could be something else entirely, like a volcanically active world. Each time a promising rocky world crosses its star, Webb will be watching, dissecting the light, and adding another piece to the puzzle. We are entering an era where we can have a legitimate, data-driven conversation about the air on other worlds. We may not find definitive proof of life next year, but for the first time, we have the right tool for the job. We are actively searching, and every spectrum Webb takes is a step closer to answering the question, are we alone? Distinguishing between geology and biology from light years away will be one of the greatest scientific detective stories ever undertaken. The technique is as brilliant as it is subtle. When a planet passes in front of its star, a tiny fraction of the starlight filters through the planet's atmosphere. Methane is quickly destroyed by sunlight, and oxygen would rapidly react with rocks and minerals. The only reason we have both in large quantities is because living organisms, plants and microbes are constantly pumping them out. It will be waiting for them to transit their star. It will be catching that filtered starlight and breaking it down, color by color, searching for that telltale bug. Is there carbon dioxide, a sign of a potential atmosphere? Is there water vapor, the solvent of life? And the Holy Grail? Is there a mix of gases like oxygen and methane that defies any explanation other than biology? Finding that specific, unstable cocktail of gases on another world would be one of the most significant discoveries in the history of science. This isn't a future capability. It's happening right now. On Earth, for instance, the presence of both oxygen and methane in our atmosphere is a screaming indicator of life. And so, as Webb targets rocky worlds like those in the TRAPPIST-1 system, it won't just be taking pictures. The challenges are immense. The signal from an Earth-sized planet's atmosphere is almost infinitesimally small, a whisper buried in the roar of a star. But the hunt is on. The approved observation schedules for the next year are packed with programs designed specifically for this purpose. Finding the universe's first light, as profound as finding alien life would be. The James Webb Space Telescope was built for another, equally grand purpose: time travel. Because light takes time to travel across the cosmos, the farther Webb looks into space, the deeper it looks into the past. It was designed to peer across more than 13.5 billion years of cosmic history to witness an event we have only ever dreamed of seeing: the birth of the very first stars. These are not just any stars. Known to astronomers as Population 3 stars, they are the ghosts of the early cosmos, forged from the pristine hydrogen and helium created in the Big Bang. They would have been unlike anything that exists today. Theory predicts they were perhaps even thousands of times more massive than our sun, and millions of times brighter. They would have lived fast and died young, burning through their fuel in a cosmic heartbeat, before exploding in supernova of unimaginable violence. It has already shattered records, discovering galaxies shining from when the universe was just a tiny fraction of its current age. Recently, astronomers announced the discovery of a galaxy dubbed JWST, seen as it was just 290 million years after the Big Bang. Using its powerful infrared spectrographs, Webb will stare at the most distant galaxies ever found, searching for the unique chemical signature of these first stars. Blindingly bright, light, an abundance of ionized helium, and a complete absence of anything heavier. It's even possible it could catch the light from an individual Population 3 star. Its light magnified 1,000 times by a gravitational lens. A cosmic trick where the gravity of a massive galaxy cluster in the foreground bends and focuses the light from an object directly behind it. This is a cosmic marvel, a discovery that challenges our previous models which suggested complex galaxies shouldn't exist so early. But in their short, brilliant lives, they performed an act of cosmic alchemy that made our own existence possible. To witness cosmic dawn, the moment the universe first lit up, is within our grasp. Over the next 12 months, as new data streams down from that lonely outpost a million miles away, we may finally get to see the first light. we may finally meet our creators. Inside their fiery cores, they forged the first heavy elements: carbon, oxygen, nitrogen, iron, and then seeded the universe with them in their explosive death. Every atom of carbon in your body, every atom of oxygen you breathe, was born inside one of these long-dead stellar giants. They are our cosmic ancestors. Finding them isn't just an astronomical goal, it's our own origin story. Until now, they have been purely theoretical. But Webb is closing in, and inside the halos of these ancient galaxies, Webb is finding clues. In a region surrounding another ancient galaxy, G/UNZI 11, Webb detected a pocket of gas that was almost pure, pristine hydrogen and helium unpolluted by the heavy elements of later stellar generations. This is exactly the kind of primordial nursery where population 3 stars are predicted to form. While Webb didn't see the stars themselves, it saw their potential cradle. It was like finding a dinosaur nest with eggs still inside. The next year will be dedicated to a systematic hunt for these cradles and the stars they might hold. This is one of the primary design goals of the entire mission. Failed stars and rogue planets. The universe isn't just made of neat categories like stars and planets. In the vast, dark spaces between the stars, there exists a cosmic menagerie of outcasts and wanderers, objects that defy easy classification. And it's here, in this cosmic wilderness, that Webb is making some of its most unsettling and revolutionary discoveries, rewriting the rules of how things are made. These are celestial objects more massive than a planet like Jupiter, but not quite massive enough to ignite nuclear fusion and become a star. They are the universe's stellar dropouts. Webb, with its infrared sensitivity, can spot them with ease, and it has already helped identify some of the tiniest free-floating brown dwarfs ever seen. Discoveries like this are challenging every model we have of star formation. The prime suspects are brown dwarfs, often called failed stars, but the real shock came when Webb stared into the Orion Nebula. It is showing us that the cosmos is not a clean, well-organized place. It is wild, chaotic, and filled with a diversity of objects that we are only just beginning to comprehend. The hunt for failed stars and rogue worlds is a journey into the cosmic shadows, and it is proving to be just as illuminating as the search for the brightest stars. It suggests nature has at least 2 ways to make planets: the familiar way, in a disk around a star, and a much stranger way, through a process we don't yet understand, in the lonely darkness. Drifting alone in the darkness, untethered to any star, it found dozens of bizarre free-floating objects. The most mysterious of all were pairs of planet-mass objects, orbiting each other but no star. Scientists have nicknamed them Jumbo's Jupiter-mass binary objects. These lonely pairs are a profound mystery. Were they born in a solar system and violently ejected together? They show us that the universe is messier and more creative than we ever gave it credit for. Over the next year, Webb will continue to conduct deep surveys of star-forming regions, deliberately hunting for these cosmic misfits. Some astronomers estimate there could be trillions in our galaxy alone, outnumbering the stars. How small can they get? Could there be rogue Earths, drifting in the cold, carrying frozen oceans, and perhaps, deep beneath the ice, the lingering warmth of a geothermal core? Or did they form all by themselves, condensing out of gas and dust just like a star, but failing to gather enough mass? Current theories of planet and star formation say these things shouldn't exist, yet there they are. This finding completely upends our definitions. These discoveries are more than just cosmic curiosities. They are fundamental clues to the story of creation. These are the kinds of questions Webb is now allowing us to ask. The discoveries we've talked about today are not science fiction. They are the active, scheduled observation targets for the James Webb Space Telescope. We are living in one of the most exciting eras of cosmic exploration in human history. If you want to stay on the front lines of these incredible revelations, and be the first to know when these discoveries break, make sure to subscribe and hit that notification bell. And let us know in the comments which of these upcoming discoveries you're most excited about. So, what will the universe look like a year from now? It will look bigger, stranger, and more alive with possibility than ever before. We stand on the precipice of a scientific sea change, driven by the data pouring down from our golden eye in the sky. In the coming months, we will receive a new gallery of alien worlds. Maybe even the first direct image of a rocky X. We'll peer into the atmospheres of the most promising candidates, sniffing for the chemical hints of life. It's a time machine, a chemical laboratory, and a planet hunter, all in one. It is the extension of human curiosity, launched into the void to answer our oldest and most fundamental questions. The next 12 months promise to be a whirlwind of discovery, a period that future generations will look back on as the moment our view of the universe changed forever. The textbooks are about to be written, and we'll be here to witness it. We'll push further back into the dawn of time, closing in on the enigmatic population 3 stars that lit up the cosmos and forged the elements that gave rise to us. And we'll continue to explore the cosmic twilight, finding the lonely wanderers and failed stars that are rewriting the rules of creation. The James Webb Space Telescope is more than just a machine of glass and gold.